here, I just want to go one more time over the types. So for the types that we have, okay, so for the types that we have, so now we know we look for a whole, right? So just reviewing what we've got on this page. We always look for a whole. We're looking for the same factor on the top and the bottom. We cross it off. We write what's left over. Okay, so that's a whole. Vertical asymptote, you're looking on the denominator. If it doesn't cross off, whole is always your first one. Vertical asymptote, you look on the bottom. You go, uh-oh, okay, so something's left on the bottom. That will always give me the vertical asymptote, denominator. Then there's the horizontal and oblique. So I want to go over those ones here. So let's go over the horizontal and oblique, and I want to talk about that. So okay, so the types that we have, so let's look at the types. I have the possibility where I have y equals, and we're going to do the possibilities. I'm going to use kind of the same coefficients. So if I have this, and then other stuff there. I have this one. Right, other stuff there. Okay, I'm trying to do the possibilities. So I have same, higher. What else could I have? Higher on the bottom. Higher on the bottom, something else there. And then what's my other possibility? What are the 4 possibilities I can have? Yeah. Higher by 1. So if I go 3x, say 3, and 4x squared. Okay? So these are the possibilities. If they are the same, okay, just want to review what we did. So same, if they're the same, we look at the coefficients, right? Because the numbers are going to cancel out. Think of that, 3 million, 4 million, doesn't matter about the remainder, it's going to be 3 over 4. So y equals 3 over 4 is my horizontal asymptote. Does that make sense? Okay, if they're the same. If it's higher on the top, then what happens? So higher on the top here, it's pulling no horizontal. Okay, because it's not going to plateau to anything because it's higher on the top. Does that make sense? Okay, the other possibility, higher on the bottom. Higher in the denominator. If that is pulling higher, you're dividing by a bigger number and a bigger number and a bigger number. What's going to happen? My horizontal asymptote would be 0. Plateauing to be 0 because it's getting bigger there. Over here, if it's higher by 1, higher by 1 on the top, then this is going to be your oblique asymptote, and you're either going to do the synthetic or the polynomial division to get a y equals mx plus b. Good? So those are the 4 possibilities we now have. All right, that's it. So that's a lot of talking I did for this one here to explain, and now we're just going to go ahead and find all of our lovely asymptotes. So much easier now. So we're going to find vertical, wholes, horizontal, and oblique. Oh, another question. Is it possible for, with my 4 possibilities of my rational function, to have a horizontal and an oblique occurring at the same time? Can I have a function that has a horizontal and an oblique at the same time? Oblique is defined by higher by 1. Horizontal is same, right? So same. So my horizontal comes from the same, or this one had none, or higher in the denominator. Does that make sense? So same or higher in the denominator. Can that be the same as an oblique? Never, right? They're contradictory. You can't. If it's higher by 1, they're not the same, and it's not higher in the denominator. So you can never, ever have a horizontal and an oblique at the same time. So if you find yourself answering the horizontal asymptote is and the oblique asymptote is this in a single question for the same function, that's impossible. You go, wait, how can I? Because horizontal says same or higher in the denominator. Oblique says higher by 1 in the numerator. You can't have both. Okay, so when I ask you the question, list all of them. As soon as you have a horizontal, you won't have an oblique. If you have an oblique, you won't have a horizontal. Okay, so you can't have both. It's impossible. Okay, so let's go through and find all of this jazz. So first thing we're going to do is find wholes. I know it says wholes second. I like to find my wholes first. So wholes, right? So whole. Can I factor something from top and bottom cancel? No, so none. Okay? I have no holes, so holes or plural holes, none. I have none. Okay. Next one, vertical asymptote. Vertical asymptote, look at the denominator. Always the denominator. Set that equal to 0. So that's going to equal 0, right? So this is going to be vertical asymptote is when the denominator equals 0, like that. So this will be x equals 2 and negative 4. Okay? Then horizontal asymptote and oblique asymptote. So we're going to do those. And they're kind of, again, like I said, kind of connected, right? So you can't have one without the other. So we're going to do horizontal. So horizontal asymptote. Horizontal asymptote looks at the degrees. So let's look at the degrees. I'm going to do this in, does the orange show up? If I go degree 1, does that show up there? It's okay to see? Okay, and then degree, tell me which colors don't work, right? So degree 2, because it's x times x. So degree 2, degree 1, right? You don't have to write that, but for yourself. So I know it's higher in the bottom, which means for my horizontal asymptote, we know it's pulling heavier on the bottom, y equals 0. Okay, please note, okay, this needs to be y equals x equals. Always do the equation. So please always do the equation. Even if it doesn't ask, we assume that you know to put it in equation form. Okay, so please do an equation. Okay, not just 2, 4, etc., etc. I want equation of. Okay, if I know there's a horizontal right away, I don't even look. None. You can't have a horizontal and an oblique at the same time. Okay. So then. Okay, so we've got that. Next one, done. So that's why. So that whole bunch that I was explaining on the other page, it just comes down to that, right? So it's actually a lot faster. Once we're doing the question, it's a lot faster, but there's a lot of explanation before. Now, let's go. Next one. We're going to do, that's all I asked for, right? Horizontal, vertical. Yep, that's it. So holes, one more time. I look for holes first. Holes, please look for first. It's the first thing you should do in every question, even if it's listed second. Holes, is there anything I can cancel top and bottom? None. Okay, then I do vertical asymptote. Vertical asymptote. Vertical asymptote, I take the denominator equal to 0. You don't have to show this, but 2x minus 5 equals 0, right? And that's going to give me my vertical. So x equals 5 over 2. Again, you don't have to show that, but that's how I get the denominator equals 0. Okay, grab that denominator, set equal to 0, and get that. And remember, x equals. So I'm not going to remind you again, but you have to make sure it's an equation, please, for all of these. Then we're going to do oblique. Horizontal. Let's do horizontal and oblique. I seem to always do it in that order. So horizontal, horizontal. Look at the degrees. I'll do this in orange. So it's degree 1 and degree 1. Okay, you don't have to write that, but for myself, that's what I'm comparing. If they're the same, I just look at the coefficients. So it's 6x and the 2x, so I go 6 over 2. Okay, and what did I do there? I went 6x, 2x, and I look at the coefficients. Okay, so the coefficients to get this. Does that make sense? So whatever the numbers are. And then you always reduce it. So yes, y equals 3. So reduce it, please, please. Okay. Next one. Oblique, none. Okay? Questions? Stop me if I'm wrong or stop me if there's questions. Okay, next one, down here. Holes? Ah, yes. So stop for a second and go factored. We love factored form. So definitely always factor, right? Factoring is our friend. So we're going to factor the question first, and we're going to go x plus 5x and then x plus 5. Okay, we can definitely cancel this out. So wherever we cancel it, we write down what's left over, so that'll be 1 over x. Okay, so what we canceled is the whole. So the whole is going to be at x equal negative 5. How did we get that? It's from here, what we canceled. right? So the whole is at x equals -5. We take the x plus 5, set it equal to 0, so I have the whole. Is that all right? Okay. Now, my new function is this. So this is my new function. So ignore that. Don't look there again. This is what I look at from now on. So when there's a whole, you cancel it and you look at your new function. If not, we don't do that. Okay, it's only for wholes. This is where we're going to look for my vertical asymptote. So don't look up here. People go back to the beginning. No, 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 no. I canceled it. I started anew. This is my new function. I know I'm going to poke out that hole later on if I was to graph it, but I'm looking at this. So for my vertical asymptote, I look here. Here, not to the beginning. Not to the beginning. We cross that off. It's gone. My new function is this with the hole in it. So don't look here for your vertical asymptote. You're only looking here to this denominator. Does that make sense? Don't go back to the beginning. Okay, mistake is that if you put that one down, you're losing a mark because you're putting a hole where an asymptote. No, so it's new. So then my vertical asymptote will just be at x equals 0. Okay, makes sense? At your new function, when it's a hole, cross it off, start anew. Okay, then my horizontal asymptote, we're looking at the degree of my new one. Again, it doesn't matter if you look to the beginning for this one, but still please look at the new one. This is degree 1, and this is degree, this is degree 0, and this is degree 1. If there's no variable, it's degree 0. There's a degree 1 here. So it's 0 to 1, right? Which means it's higher in the bottom, which means the bottom's getting bigger faster. So that means it's going to 0. I always picture that. It's like I'm dividing by a bigger number, so it's going to go to 0. And since I have that, I don't even think none. Don't have to look for the oblique because I already decided it was horizontal. Okay, next one. Questions with that? We're okay? Whole? Can I cancel anything? Factor? I could factor the top. You don't have to. It's x minus 2, x plus 2. It's still not going to cancel to be a whole. So wholes, none. Okay. Vertical asymptote. I can see denominator x equals 0. We're okay there. Okay, you're getting that fast now. Horizontal asymptote. Look at the degrees. Degree 2. Degree 1. Higher on the top by 1. By 1. 1 higher. 1 higher. Cool. Now I get to put none here, and I get to find my oblique. Okay. I did this one on purpose because I thought this would be super fun. Can I do synthetic? Is that a linear on the bottom?
Yeah.
Yes. Can we do synthetic with an x? Yeah. Sure. Let's do it. So we're going to do synthetic. I'm going to do this on the side here. So we're going to do synthetic. Remember that this, I'm going to rewrite it just in case you don't picture the 0. So it's going to be x squared plus 0x minus 4 divided by x plus 0. Does that make sense? I'm rewriting that. So I just rewrote that. X squared 0x, make sure you fill in the 0. So this will be 1, 0, negative 4, right? Filling in the 0 and just highlighting this. Right, so fill in the 0. Also for this one, you're filling in the 0. So it's x plus 0. What do I put here on the side?
0.
0. Okay, 0 works. Okay, and then you're just going to work the way it normally does. Right, so 0 does work. So if it was plus 2, we'd put negative 2. If it's a 0, you put 0. It's fine. Drag down the first one, so it's 1. 0 times 1 is 0. Add the zeros is 0. 0 times 0 is 0. Add it, you get negative 4 remainder. Good. So we got a remainder. And then my equation is, okay, one more time. What's the equation here? Y equals, so y equals, and that is x. And then plus 0, nothing. So that's fine. It's a linear equation. It does work with 0 here. Sometimes that throws people off, but it does work. Any linear can divide in. So you're, instead of plus 2, it's a 0. So you put 0 here, it works. You get your y equals x plus 0. That's fine. You can even picture it. Sometimes you go, wait, but x goes into x times, and then you have the remainder because it won't go in the rest. Okay, I get it. Right? So when you're dividing it in, but sometimes you want to do a check on the side. So my oblique asymptote is y equals x. Yes? Yeah, yeah, because that's, for remainder for the 0, yes, exactly. Yeah, exactly, yeah. Okay, so if you can do it faster, so once you go, you wait, if it's 0, I'm just dividing the x in. Yeah, so if the question is, can I do that faster when you divide in, you know the remainder's there. Yeah, you can definitely do that faster once you see the x is dividing in. Yeah, okay, so if that was like a 2x squared and that's an x, it would just be 2x, exactly, right? So if you can do that faster, do it faster. If you're like, I want to reassure myself, then do the synthetic. Okay, but after a while you go, oh, actually I can see the pattern there. So I want that. I think that's all I want, yes. And then that's all. So right on this section, we're just listing them. We'll do more with it later. Okay, and then last one here is going to be holes. Any? None? Okay, nothing that factors in. Vertical asymptote. Are we getting that now? So we look at the bottom, set it equal to 0. X equals 5/3. Okay, and again, you can show more work if you want to on the side. I just want the answer. And we're remembering always equations, right? So all of these are equations, right? All of these are equations. Okay, and then horizontal or oblique. Okay, we're used to this now. It's going to be degree 0 and degree 1. Bottom is bigger. It's getting bigger on the bottom faster. It's dividing by a bigger and bigger number. So y equals 0, oblique asymptote. None, since there's a horizontal. Any questions with that? Yes.
Just a question about oblique asymptotes. So if there is an oblique asymptote, that means there's no horizontal or vertical asymptotes at all?
No. Oblique and horizontal, these two connect, but there could be a vertical. Okay. So there can be a vertical if there's an oblique. So the graph would look something like this. We get sometimes a dot there, and we get a nice little oblique. And look, sometimes our graph looks like this. It's really beautiful. We're going to be doing more of these in the next section. Yeah, so you can have a vertical with an oblique. You just can't have an oblique with a horizontal. Yeah. Okay, so anything else goes. Any other questions? Yes, the question was, can you have, yes, you can have, you can't have those ones, but you can have a vertical with the oblique. All right.